Okay, let's get started. So good afternoon, everyone. Thank you for coming down today. When we managed to pull a crowd on the afternoon session of the second day of a technology conference, I think that means we're doing pretty well. So thank you for coming down. Thank you to everyone on the live stream as well. I know some of you have gotten up very early in the morning or have stayed up very late in the evening to watch this. It's really exciting to see you all here, either physically or virtually. We've got some really cool stuff to show you. So my name's Andrew. I'm a product manager on the Google App Engine team. I work with the runtimes teams here in San Francisco. I'm going to be your, I guess, cabin assistant for the next 30 minutes or so. And at the controls here at the front, up on stage, is our highly experienced pilot for this session, who's also the lead engineer on what we're going to show you today, Mr. Stuart Langley.
Thank you very much, Andrew. It's great to see so many people come down interested in PHP. Obviously, this session was formerly known as the new language for App Engine, and as announced yesterday, we've actually launched PHP for App Engine. It's a very exciting time for us, and it's great to see so many people interested. But before we can really get started on the topic of the presentation, this is one final thing that we'd like to do before we get into it, which is actually mark the bug in the issue tracker as officially started. Like, as engineers, we like to measure our milestones as acknowledged, started, and finished. Unfortunately, we can't say finished, but we can definitely say started. So while Andrew gets us underway, I'm just going to jump into the issue tracker here and let the people that aren't at I/O and perhaps haven't been watching the news for the last 24 hours or so, that the most popular feature or the most requested feature ever in the history of App Engine has been delivered, and the progress is underway. So, Andrew, thank you.
This is a big moment for us, guys. Okay, so 3,300 people, I think, starred that feature. Google App PHP is now available on Google App Engine. So PHP is the most popular language by many accounts for writing software for the web today. And that's perhaps not particularly surprising. It's a language that from day one was designed with the web in mind. It was designed to make it easy to stand up anything from a web form to rich, complex applications, things like content management systems or e-commerce sites or even back-end enterprise office software. And Google App Engine, of course, is a platform that allows you to take your code in whatever language it might be written in and bring it to the web with Google's infrastructure, the same infrastructure that we use for products like Gmail and Maps and Picasa and many other services. And what we're going to show you a little bit of today, and at least give you a taste of, is how you can use some of that same power, some of the same phenomenal elastic bursting capability that App Engine gives you, some of the phenomenal availability and reliability that App Engine gives you as developers with PHP with your own applications. So I can stand up here sermonizing for a while, but why don't we just get into the meat of it? Why don't we get into a real demo on PHP, Stuart?
Good idea, Andrew. So, look, actually, before we get to the demos, why don't we try and answer the question that most people probably have in the tips of their minds, which is how have we gone about bringing PHP to App Engine? Are we using something like hip hop running in App Engine? Are we running something like PHP in a JVM on top of Java in App Engine, or even something more exotic than that? And quite often the simplest answer is often the most correct. And what we've actually done is taken the open source PHP 5.4 interpreter that you would get from php.net, downloaded that and hardened it to run in the App Engine environment. So the good news there is if you have an existing PHP 5.4 application running somewhere, it will be very straightforward for you to actually forklift that application into the App Engine environment to take advantage of App Engine services and the Google Cloud Platform as a whole. So now that we know it's open source PHP 5.4, the next question that we can answer is what extensions have we compiled into the interpreter? What's available for you as application authors to use when you're writing your applications for App Engine? So at this point, we can probably jump into a quick demo. It looks like we actually updated the bug, which is good news. So what we have to demonstrate this to you is a really simple web shell application running, look over this way, PHP 5.4 in Google App Engine 1.8, which is what we just released. And what I can do here is ask it to tell me the extensions that are available. So because my live coding skills are somewhat subpar, I'm going to do a cut and paste here. But essentially, we're just going to get what extensions have been loaded, sort them so it's easy for us to have a look what's there, and then print them on the screen. And if you're actually hitting this application now, which is running on appspot.com, you might be getting an error or two, basically because I've locked it down, so only I can access it at the moment. But I will fix that shortly, and this application will be available to everybody. However, so now we see what extensions we've got available here, and we think we've sort of captured a reasonable set of extensions for the most common PHP applications that are being written today. We have APC, so you have opcode caching available, GD for graphics with JPEG, PNG, and FreeType. And for application interoperability, we have XML, SOAP, and OpenSSL. And obviously for SQL, we have the 3 variants of the MySQL API. And so I figure there's probably an easier way that I could have shown you this information, as PHP comes with a built-in function which will actually show you a lot more about the interpreter than I could ever hope to say standing up here in half an hour, which is obviously PHP Info, which is probably the first script that anybody ever using PHP would write. But running it in the shell here with the output going into our terminal window is not very informative. So what I was thinking we might do to illustrate how easy it is to develop applications for App Engine and to test them locally and to push them up is to actually add a page to our app here, which will run PHP Info and push it up and let people hit that page and see what's there for themselves. So if you're familiar with developing apps for App Engine using Python and Java, you're going to be very familiar with the next steps I'm going to show you. But I'm hoping that there's a bunch of devs in the audience or watching online that have never tried PHP, they've tried PHP before obviously, but they've never tried App Engine before. So I'll take 3 minutes of your time to add a new page to my app, test the app locally, and push the app up to production and make it available. And while I'm at it, I'll remove the restriction that I had before so that anybody can use the application. So this is basically the listing of the files that are in my app. We have a few PHP files and some static resources that we use as well. The interesting file that you might never have seen before if you've never developed for App Engine is the app.yaml file. So we can quickly have a look inside of there. And essentially what this is the configuration of your application so that we know how to host your app. For a simple application like the web shell app, essentially it's the metadata at the top which is describing the name of the app and the runtime that this application is using, in this case the shiny new PHP. And the bottom section is essentially the handler mapping, which we use to map incoming URLs to either static resources in your app or to the scripts that should be executed when those URLs are accessed. So what we'll do, we'll quickly add a new script. And this is where typing is going to be interesting. So we'll quickly add a new script to call PHP Info when it's accessed. Could not be simpler. And now what I need to do to get this to work with my application is actually add a new section to the handler section at the bottom here, which will map an incoming request to that script that I've just created. So let me just go down. Looks like I can't cut and paste for some reason, so we're going to type. So what I'm going to do is create a mapping from a URL of PHP info to execute the script PHP info.php that I just wrote. And I promised you that I'd remove the restrictions that I placed on this application from anybody using it, which is actually the bottom line in the app.yaml file here, where I've said that only administrators are able to access the last URL, the front page of the app. So what I'll do, I'll just go down and delete that and save my app.yaml. So I think my app's ready to go, but I don't want to push something into production that I haven't tested. So what I'm going to do is use the DevAppServer tool that comes as part of the SDK that you download to write apps for App Engine. And what DevAppServer is a complete simulation of the entire production environment that runs on your machine without you having to have gone and configured any services that we might have running. So for example, Memcache or task queues or cron or things like that all work on your development box, and you can debug PHP apps without you having to actually retrieve the services yourselves or set the binaries up yourselves. So my development server started, and the most important line is the second last one from the bottom, which is it saying that it's waiting on 8080 on localhost for a request for this application. So what I'm going to do is just jump over and go to localhost. And we can see the same web shell that you saw running in production running on my local machine. I've got a slightly more recent version of PHP on my local machine, but the host has now changed to development 2.0. The app works as you would expect it to do in production on my local machine here. So what I didn't mention before is this app's actually stateful. And between requests, we can assign values to variables and then get them on later requests. And we do that using sessions. PHP developers are obviously very familiar with sessions, but in this case, it's backed by Memcache. And so I have Memcache running in my local environment here. Everything's working fine without me setting it up. But we're not testing the shell, we're testing that the new script that I added works correctly. So let's hit PHP info, and you can see it's going to call my script, and it's actually showing you PHP info for PHP that's running on my local machine. And so I think that I've successfully added my script, and I've set up the handler for it. So let's push it up to production. The way that you push to production, and I'll sort of type and talk at the same time here, is another tool that you get with the SDK, which is AppCFG. And AppCFG looks at the app.yaml file that I showed you before to understand the structure of your application and how we should deploy that up to production, and to make sure that we put your static assets in the right place and your dynamic assets in the right place. And well, that was quick. So it's pushed my app up to production already, and it's actually even already checked if that version that I pushed up is serving back to me. So what I should be able to do now is go back to my instance that I have in appspot.com and hit PHP info. If I don't make a typing mistake. And there we have. So I've successfully deployed a new page to my app, tested it locally, and pushed it up to production in hopefully 3 minutes or so. And as I mentioned, this should now be freely available to anybody to go and try out the interpreter and actually have a look at the PHP info for themselves to see what we've actually provided in the interpreter.
So, you know, Stuart, I mean, that's a great demo, but I mean, let's be honest, there's probably not that many people in the room who make a living out of pushing mini-shell applications up. And we did promise everyone a real application here. Have you got, I don't know, have you got WordPress or something like that that you can show?
Funnily enough, Andrew, I thought you might ask if I had WordPress. And as it turns out, I do. Let's just have a quick look. We'll do this really quickly. This is not a WordPress demonstration, it's an App Engine demonstration. So what we have here is WordPress running on appspot.com. This is already public. You can go and have a look at GAE for PHP blog.appspot.com. But people that have deployed WordPress sites before would recognize this as basically what you would see when you first deploy a fresh site and you haven't configured it or haven't changed the themes or the styling. And so we're using basically the theme that comes out of the box, and we haven't made a post yet. But you know, a blog without a post is a pretty lonely old place, so let's quickly just jump in and make a post. Once again, if you've used WordPress before, you'd be familiar with the administration console, which is where you go and configure everything and do your posting from and configure your plugins. And we're going to do a post, so we'll jump on the post tabs here. And luckily enough, I've already pre-canned something, have it ready to go for the purposes of the demonstration, which is a new page. Andrew checked this out before and he's happy with the content of it. And what I'm actually going to do as well is use Jetpack to make a tweet when we do the post here. And so on the side here, I've got my Twitter settings. I'm pretty happy with the hashtags, but I just remembered that I forgot to add Andrew and his legions of followers to the post here. So let me just add that in. And hit publish. And WordPress will go off and do what WordPress does best. And publish our post. And we can see at the top there it's saying post publish, view post. So let's quickly jump in the front there and look at our front page, and hopefully we'll see our shiny new post. There we have it, WordPress post working.
So, so this is WordPress running on App Engine. And by the way, these sites are both live that we've demonstrated to you. So both the blog, GE for php-blog.appspot.com and php-minishell.appspot.com. They're both live now if you can get through the Wi-Fi. They're both live now if you want to go and check them out. Now, when Stuart showed me this demo a few weeks ago, it blew me away. And the reason why, and if you've ever tried to stand up something like WordPress, then you'll know this. To run something like WordPress, actually, it takes PHP, but it takes a lot more than just PHP. It really takes a full stack of services. In fact, it takes what you might call a platform to really pull an application like this together. For one thing, you need a database. And not just any database, but you need a fully relational database, and one that understands a pretty sizable subset, if not the full subset, of SQL commands that these kinds of applications have come to expect. Fortunately, we have that in the form of a product called Google Cloud SQL. We'll talk a little bit about that in a second and some of the optimizations that we've made for Cloud SQL and App Engine and PHP in particular. Another thing you need to do when you're writing applications very frequently is write to some kind of file system. And historically, if you've worked with App Engine, then you'll know that's been a challenge. We don't allow writes to the local file system that your application's deployed on. We do that for reasons of security, as well as reasons of scalability. But we do need somewhere to write files. If we wanted to upload an image as part of that blog post, for example, we'd need somewhere to put the image. We'd need somewhere to serve it so our users can see it. So we need a scalable distributed file storage system, and we have this, of course, in the form of Google Cloud Storage. Again, we've made some optimizations so that it works well with PHP. We'll talk about that a bit in a second, too. And then finally, when standing up any application, there's a ton of other services that tend to come in pretty handy. Things like Memcache for adding efficiency to your application. Things like a mail service that can send mail reliably and efficiently. Things like task queues that allow you to dispatch and asynchronously run long-running processes. Again, we'll very briefly, because I know we want to get to questions, we'll very briefly cover some of these as well. So let's start with Cloud SQL. So Cloud SQL is our fully managed MySQL 5.5 compatible database service. And the key phrase in there is fully managed. It's, you don't need to shell into an instance and set up a MySQL server and configure it and then write a backup script and then set up read replicas and all of that sort of thing that you would normally need to do for a reliable MySQL cluster. This is fully managed. You go into the Cloud Console and you turn it on. It's really simple. It's also highly durable. What that means is when you write to Cloud SQL, we actually propagate that write out to multiple data centers. And that gives you what I, being a product manager, like to call meteorite level reliability. In other words, if a meteorite happened to hit a data center that your app happened to be serving out of, you wouldn't necessarily lose any data, and in fact, your app would still keep serving. We provide automatic backup and one-click restore, which if you've ever tried to roll your own backup system, you'll come to appreciate very quickly. We also have a really interesting pricing model with Cloud SQL. With Cloud SQL, you can price it on a per-hour basis in the same way that you would do with many other hosted SQL services. But we also have a pricing model that allows you to pay for Cloud SQL only for the increments of time that you actually use it. That is, the increments of time that you read and write to the database. And so if you have staging databases and QA databases and maybe even development databases floating around that you don't actually use very often, maybe only a couple of hours a week or a few hours a month, that's actually really economical. You can save a ton of money by using Cloud SQL and using that pricing model. But most importantly, I think, for this audience and this talk, we've optimized it for use with Google App Engine. We've done that in a couple of ways. We've optimized the security. You specifically bind a Cloud SQL application to an App Engine app, which gives you an extra level of security over and above what MySQL itself gives you. We also optimize it for performance. And we do that by co-locating the Cloud SQL instance along with your application so that the application you're running in and the database you're using are physically proximal to each other so that connections between them are very fast. So that's Cloud SQL, but let's look at what it looks like inside PHP. Now, if you've ever worked with MySQL and PHP before, I'm sure many of you have, then you'll know, first of all, that PHP makes it easy. But second of all, that PHP makes it easy with 3 different libraries. There's the MySQL library, the MySQLi library, and the PDO MySQL library, amongst possibly others. And the good news is, with App Engine and Cloud SQL, we've optimized it to work with all 3 of them. And in fact, there's not really much to say about this, except that it works exactly the same way that you would expect with a MySQL database that you might have running on your own instance or running on your own box somewhere. The only real difference is that rather than specifying the name server or an IP address of a MySQL server somewhere, instead you specify the project name and the instance name of the Cloud SQL instance that you've created, and this socket Cloud SQL identifier here. Everything else, querying, selecting a database, is exactly the same. So that's Cloud SQL in a nutshell. Let's talk about file storage. So again, with file storage, we wanted an object store system that was as scalable and efficient and performant as App Engine itself was. And Cloud Storage gives us this. It has a couple of pretty interesting features, one of them being fine-grained access control. So like like any object store, like any file system, really. It gives you the ability to be able to control exactly who can read and write to what files and what collections of files. It also allows you to publicly publish content to the web if you choose. If you set the bit on a collection of files or on a specific file, you can publicly serve that image to the web from a HTTP address that you get given. So it's actually great for serving content that might get uploaded as part of your application or generated as part of your application. And then there's many different ways that you can get to those files once you've created them. There's a web-based GUI, if that's what you like to use. There's any number of RESTful APIs that the cloud storage service gives you. And then, of course, you can get to it from Google App Engine. Now, let's look at some code for getting to cloud storage from PHP and Google App Engine. So PHP has a number of functions that support a streaming API. And within the streaming API, you can specify what resource you want to access by the URL that you provide. And you've probably used these functions before if you're a PHP developer. These are things like fwrite and file put contents. And you might have used them with URLs like a file path or possibly an actual URL, like a HTTP URL. What we've done with Google Cloud Storage is include cloud storage as a first-class citizen in this streams interface, which means effectively that you can specify a cloud storage object or a cloud storage bucket with these calls. So to fwrite to a file, for example, to write to a file is as simple as fopening a cloud storage bucket that's been set to be able to talk to your app. You can then write data into it just like you would write data into a normal file, and you close it just like you close a normal file. Similarly, functions like file put contents and file put contents work much the same way as if you were working with files on a local file system. And the good new thing about that is it makes it really easy to put content and retrieve content from this high-performance storage system that we have. So that's a couple of ways that we've talked about to store data. Let's very quickly talk about a couple of ways to make your application more efficient. And again, for those of you who might not have used App Engine before, or you have, but maybe it's been a while, both of the features that we're about to talk about are fully emulated, not just inside App Engine itself when you push your applications to production, but they're also fully emulated inside the development server itself. So you don't need to set anything up on your laptop or on your development box in order to be able to use this stuff. It's automatically there with the development server. So the first thing I want to talk about is Memcache. Memcache is a great way to store content that you need to access frequently and you need to access quickly. Session data is something, for example, that you might want to store inside Memcache. Something that's computationally expensive to produce, maybe something that involved a few database calls or a few CPU cycles, is something that you may well want to store inside Memcache between requests or between sessions. One example, actually, that we showed you before, but we didn't tell you, was the blog that we set up was using a Memcache plugin called Batcache to cache the pages that have been generated. And that actually worked, interestingly, out of the box. We didn't need to modify any code. And in fact, PHP provides two libraries to work with Memcache. It provides the Memcache library and the Memcache library. They're similar but different. And all you really need to know about how they are treated inside PHP on App Engine is they work exactly like you'd expect. And again, we found a lot of code that we've worked with generally works by simply dropping it in. We don't need to make any modifications to it. So another way you can add efficiency to your applications, as well as some scalability and some reliability, is using task queues. Now, task queues are possibly my favorite feature of App Engine. And in a nutshell, what a task queue is, if you haven't used it before, it's a way of taking a long-running piece of work, let's call it a task, that you would have otherwise running inside the request-response cycle of your application, and that might delay the response to your users while you're waiting for this task to complete. And task queues allow you to take that unit of work and run it asynchronously outside of the request-response cycle. And what that means is, instead of waiting for long-running processes to complete, your application can respond much more quickly. You can respond effectively immediately to your end users, so they get a snappier response and they get a much better experience using your service. So again, just to put a bit of context in here, an example of that might be when Stuart published his post on WordPress before. We actually had a little plugin there called Jetpack, which allowed us to tweet to our legions of followers. And you might have noticed when he pressed publish, it actually took a short amount of time. It took about a second or so, which is pretty fast. But a large amount, the reason that it took so long, a large amount of that time that we were waiting was actually waiting to go out to the Twitter API, send the tweet, get a response back. Twitter has a great API, and it's pretty fast, but calling any third-party service takes time. So something like that is an ideal thing to wrap into a task and to run asynchronously. Let's quickly look at some code that does that. Now, and this is rather contrived code because we wanted to fit it on a slide, but I think from here you can get the idea. There's really only two steps. The first step is to create a task handler. This is just a normal PHP file, and all we've done inside this task handler is put the code that we would like to have executed asynchronously. In this case, it's the code that sends a tweet. And we want this task handler, we don't want it to send just one particular tweet. We want to be able to parameterize it so it can send many tweets. And so what we've done here is you can see that the text of the tweet is specified by a post variable. And then back in the original code that was publishing the blog post, here we've called it post.php, what we've done is take the original code that was sending a tweet and replace it with this new push task object. So we include the push task library, we instantiate this push task object, we initialize that object with the path to the handler that we've just created, and we send it any parameters that we think are important, again, in this case, the text of the tweet, and we call this add method on it. And that add method will then execute very quickly. It will asynchronously dispatch the tweet task. It will run outside of the request response cycle, and your application can get back to your users really quickly. So it's a really nice way of improving performance. You can also take advantage of things like retries in case the tweet call happened to fail for some reason. So now, there's a ton of other stuff that I was hoping to have time to talk about today. There's things like our page speed service, which automatically rewrites your JavaScript and CSS and HTML, so it renders quickly for your users. There's things like our URL fetch service, which actually takes the same infrastructure that we've been using for years to crawl a web. Google does a lot of that, and makes it available to your application for fetching and posting HTTP content. There's services like our users API. There's services like our mail API that allows us to send content really quickly and efficiently. I really would love to talk about them, but we are running out of time. So what I'd like to do instead is give you a bit of a taste for how this runtime works in the real world, with real deadlines, real clients, and even real users. So in order to do that, I'd like to hand over to Jason from Potato. Potato are a wonderful agency. They've been working with App Engine for quite a few years now, I think. And they were one of the first people to get access to the PHP runtime when we were running privately and trusted tester. So, Jason, we'd love to hear your experiences.
Cheers. Thanks very much for inviting me along. So, hey, I'm Jason from Potato. We're a web development agency with a very silly name. Based out of London, we've got people in North America, Europe, and Australia. There's about 70 of us, and we're almost all developers. So we build marketing-based web applications, often for marketing departments. These are applications that live and die around a campaign, usually around like a media spend or an event or a launch. And we love using Google Cloud Platform because it allows us to scale up to thousands of simultaneous users and many thousands of requests a second. But also, less glamorously, it also scales down as well after the initial deluge of users, which is a lot less glamorous but important for costs. We do this with almost 70 developers, but no sysadmins, and nobody carries a pager. So, let's have a look at an existing Drupal website that we got up and running on App Engine. So this is datavizchallenge.org, and it's a site that hosts a competition that allows developers and artists to visualize how US tax dollars are spent in interesting and informative ways. And it's all built using Drupal. So what isn't so cool is that it was previously hosted on a single server in a single data center that was about to be decommissioned. But I think we've just heard of a platform that can fix that. So let's see how our developers, John and Asim, did it. So the first stage was to get it running on the development app server. And as Stuart showed you before, you're going to need an app.yaml file for that. This is really familiar if you've used App Engine before, and very straightforward if you haven't. You've got your application metadata, and then some regexes at the bottom that route your scripts. So previously, we got it up and running, and then we found out that the the previous installation using Apache was using htaccess files to redirect the URLs so that the Drupal permalinks worked. That was really easy to solve. We just put a router script at the top of the application to give Drupal the information it was expecting in the place that it expected. From there, we took a standard MySQL backup dump, just a big fat SQL file, from the live production database. We then uploaded that to Google Cloud Storage, very straightforward, and then from there, it's one click to get that into Google Cloud SQL. Then, we changed the connection string, so just like Stuart showed you, very straightforward if you've used PHP before or other scripting languages, just a string that tells the script where the data is. And then it's just one command, like any other App Engine application, just one command to put this, to hand off your code to Google and for them to run it across as many server instances as is required. So we gave the site a bit of a load test just to see what would happen. And we gave up trying to break it at about 800 requests a second. It didn't go down. So, and also today I just found out it's using Memcache. We did nothing to set that up. It just worked straight out of the box without us even knowing about it, which is really cool. Overall, we were really impressed by how a young platform, and we were using it before it was released, was able to take this relatively complicated content management system with customizations on top and scale it up.
Thanks, Jason. Cool. So that's awesome. So that you've seen WordPress, now you've seen Drupal running on App Engine too. That's pretty cool. So this week at Google I/O, we've announced App Engine into limited preview. So what does that mean? Well, first of all, it means that both the documentation and an early version of the SDK are available today from our developer site. That's, you can't quite read it there, but that's developers.google.com/appengine. So you can get both of them right now, and you can use that to start developing stuff locally on your own machine. For a limited time, to actually deploy an application, you will need to be whitelisted. To do that is very, very simple. Just head on to cloud.google.com/appengine/PHP. There's a self-service site to get set up, and we'll be whitelisting you as soon as we can. If you're actually physically at Google I/O today, then there's some great stuff going on. You can find both Stuart and myself in the developer sandbox after this event. We'd love to have a chat to you and answer any PHP questions we don't get to right now. And we also, for those who are sticking around tomorrow, we have a code lab. And we, again, both Stuart and myself will be there. And we'll be going through a lot of the techniques and a lot of the libraries that we talked about today in more depth. And again, we'll be able to answer questions. So now we would like to take it over to questions. So we've got, again, for those in the audience, we've got a couple of microphones up here, which if you come up to, I believe will be turned on and you can ask questions. Do we have any online questions?
We don't, Andrew.
Beautiful. So it's open to the floor.
Okay.
And I believe, sorry.
When you run WordPress on any server, typically there are many plugins, and WordPress itself gets updated automatically these days. So when you just see in the web console, it says there is an update, click to update, and it automatically downloads and does the update itself. So how does it work in App Engine context? Because in App Engine, there is no file system, so does the same functionality work, or do I have to go back to the old SVN method of downloading updates on the back channel and pushing the update into the App Engine?
So essentially you've answered your own question there. So my understanding is, does the update feature that's part of WordPress, where you can just point it at the zip file for a plugin, for example, and have it upload and install that plugin in your environment, work on App Engine?
Oh, that's part of it. But the second one is, let's say WordPress, my primary question was, if WordPress gets updated, say from 3.3.1 to 3.3.2, we don't need to manually push the updates these days. WordPress can automatically download it by itself.
Sure. Okay. I think
does it work?
Sorry, I believe I understand your question. So the answer for both, as Andrew already mentioned, in the App Engine environment, you can't write to the local file system where we serve your application from. Right. And we will, as it stands at the moment, we will not let you execute files that you put in Google Cloud Storage. We treat them as URLs, and we don't let you include them. So to update the plugins that you may have, or to add new plugins to your runtime, would mean repushing your app much like FTP. And the same thing for migrating from one version of WordPress to the other. You would need to repush your application.
Okay.
Before you sit down, I believe we have some swag for question answerers at the front. Please come and collect.
Sure. Next question.
Thank you for presenting PHP on Google App Engine. I have a question about using framework. I make an application with PHP and so many famous frameworks. Example, Symfony or Cake PHP. If you tried it, please tell me what happened if I used some frameworks in App Engine.
So we haven't spent a lot of time experimenting with frameworks on this yet. So
we haven't, but a few early trusted testers have taken things like Drupal, for example. There was a blog post last night on actually how to stand up Drupal, and people have started looking into Symfony, Cake, and so on and so forth. But personally, we haven't tested them a great deal, and I think part of this project is working closely with the communities that write these frameworks and use these frameworks to understand what needs to happen on our side for them to work, and also to help them make their frameworks run well in App Engine.
Okay, thank you very much.
And just a quick public service announcement. If there's anyone who would really like to be whitelisted early, we have a very small, a limited, I think 10 invites that we can give out.
I believe that we were going to question askers were automatically going to get whitelisted. So you're doing the right thing in the line there. But if we don't get more than 10 question askerers, come and find us and we'll do our best.
Absolutely.
So to the left.
So you showed example of Drupal, you showed example of WordPress, and you said that there was next to no changes that you had to do. One of the big things on both of those is, they have file uploads, and I know you've done a good job of just having URL handlers for that, but both Drupal and WordPress require you to then say what the URL path to those are, and if it's on Google Cloud Storage, it's going to be elsewhere, and if I'm not mistaken, the default for Google Cloud Storage is not to be publicly readable, so wouldn't you have had to make changes to that in order for file uploads, even though they're be going into Google Cloud Storage to work?
Sure. So so we're actually certainly in the case of WordPress, and hopefully in the case of Drupal, we're looking into plugins that can help with that. So there are for uploading media, for example, and uploading other types of files to Google Cloud Storage. That's something that, while WordPress itself won't necessarily do out of the box, it's something that can quite easily be solved with a plugin. So in the case of WordPress, that's something that we're working with a few people in the WordPress community to try and bring to bear. And we'd like to see the same thing with Drupal as well.
From the right.
Hi, I'm a PHP developer. I'm also a Ruby on Rails developer. I was just wondering, I use various platforms such as Heroku and Cloud Foundry, and I was wondering, when will you guys support Ruby on Rails?
So, that's a great question.
Well, the thing is, with PHP, there's so many frameworks. You have CodeIgniter, WordPress, and all these other frameworks. But with Ruby on Rails, you have Sinatra and Rails.
Yeah.
So.
No, Rails is a great runtime, and we're always, so the work for us doesn't stop at PHP, just as it didn't stop with Python or Java. We're always working on more, and we're always looking into new runtimes. So expect more from this space. I can't unfortunately talk about things that we haven't announced yet, but expect more to come.
Where can I follow for news regarding new development?
So there's a couple of places actually. The Cloud Platform blog that we announced recently is a great place to start. We have, I believe, a Google Plus profile as well. And then on top of that, the forums as well are a great place to find out. The forums actually there were some people on the App Engine forums that found out about the PHP runtime before we'd even announced it. So if you want to find the real early news, I'd recommend that as a place to start.
All right, thank you.
So I believe, unfortunately, we're out of time. I understand a lot of people want to ask questions and get whitelisted. Please don't think that we're trying to stop you from doing that. Come and find us outside, and we'll do our best to get that done. All right? So thank you all for coming today.